And now let's take more examples on angle of elevation and depression. The first things we need to know is, let's take a quick recap. The angle of elevation is the angle when looking upwards from a horizontal line. The angle of depression occurs when we are looking downwards from an horizontal line. And remember, we always use the right angle triangle principle to solve the problems, as well as the correct trig ratio, or based on the given values. So the trig ratios in this case is simply considering Catwa. Now let's solve together these questions. The first question says a person standing 40 meters away from a tree observes the top of the tree at an angle of elevation of 35 degrees. Find the height of the tree. As usual, let's duplicate so that we'll have it ease of access. Now let's say we have a tree and the person is standing away from, he starts standing 40 meters away from a tree. The person is here, B, and observes the top of the tree. This is the top of the tree, T, at an angle of elevation of 35 degrees. So we have an angle of elevation of 35 degrees. We are asked to find the height of the tree. And now if you look closely to this, always use the right angle triangle principles to solve problems. So we have the right angle triangle here. So it's simple. We are looking for the height of the tree. The distance away from the tree is 40 meters. And we have an angle of elevation of 35 degrees. What is the height of the tree? This is the opposite. H is the opposite. 40 is the adjacent. And we have the hypotenuse. So with this, we can simply use tan theta is equals to the opposite divided by the adjacent. The opposite in this case is H, what we are looking for, which is the height of the tree, and the adjacent is the distance from the tree, which is 40. And our tan theta is 35 degrees. So simplifying further, we have H to be equals to 40 multiplied by tan 35 degrees. So we have 40 multiplied by tan for 35 degrees is 0.7002, and we'll have the result to give us 28.01 meters. So we have been able to evaluate the height of the tree using the TOA operation, which is tan theta is equals to opposite divided by adjacent. Moving on, let's take question number 4. So we duplicate it, move downwards onto the new page. The question says an airplane is flying at an altitude. An airplane is flying at an altitude of 3,000 meters. A controller is at an airport tower and sees the plane at an angle of elevation of 20 degrees. Find the horizontal distance of the airplane from the airport. So let's take, for instance, we have an airplane flying. Sorry, I'm not so good with diagrams, but let's just have an airplane. Okay, we have an airplane flying at an altitude. So the distance of the airplane to the ground is 3,000 meters. So let's say call this place the ground or the airport. Ground is 3,000 meters. Now a controller is at an airport tower. Let's call this the airport tower, which is the base ground, base control. The controller is here, controller C, and it sees the airplane. He's watching the airplane probably with his binoculars at an angle of 20 degrees. And now we are asked to find the horizontal distance of the airplane from the airport. So this is the airport, the horizontal distance x. Remember, we are solving using right angle triangle principles. So with respect to that, we can easily find the horizontal distance. So with this, let's draw a simple diagram to represent this. We have the height, the altitude to be 3000, the angle is 20 degrees, and we're looking for x. So this is similar to what we solved earlier, because now we have opposites to be 3000 and our adjacent to be 3000, but this time we are looking for the adjacent. So we also apply tan theta, which is equal to opposite divided by adjacent, and our theta in this case is 20 degrees. Therefore, we are saying the opposite is 3000, and we are looking for the bare horizontal distance x, which is the adjacent. So simplifying further, let's make x out of formula. So the horizontal distance x is equal to 3000 divided by tan 20 degrees. Using our calculator to find the expression of tan 20 degrees, we'll allow it to give us 0.3000 divided by 0.3640 to give us x, and using dividing it by 3000, we'll have the horizontal distance to be equals to 8242.43 meters. So we have evaluated the horizontal distance to give us 8242.43 meters. So that means we have the horizontal distance evaluated. Now let's take an exercise on angle of elevation and depression.